Good morning to all. In this video, we are going to discuss about the quadratic probing in the data structure under the collision resolution methods or strategies. Okay, before we get into this topic, first we will have a quick recap on the hashing. Hashing, it is a mechanism which is used to store large volume of data into a small table. While we are storing this, we have to use the hash function. Hash function is the mathematical equation which is used to find out the positions to store the value. Okay, the hash function, there are three types of hash functions are there: division method, mid square, and the digits folding. We can adopt any one function to find out the index positions to store the values. Okay, when we are storing that large volume of data into a small table, there is a lot of chances of collision. The collision is nothing but the two or more key can request the same index position to store the value. Okay, in that case we are having a mechanism to avoid those collisions. So the collision resolution strategies are two types: separate chaining and the open addressing. Open addressing, again, it having a three methods to solve the problem: linear probing, quadratic probing, and the double hashing. In this video we are going to discuss about the quadratic probing and the double hashing. Quadratic probing, it is a open addressing scheme to find out the resolution for the collisions. Okay, it have the take the original hash index and adding the successive values to the arbitrary quadratic polynomial until the unoccupied slot or open slot is found. For that, the equation is hash I of x equal to hash of x plus I square plus hash table size. This is the equation to find out the place. Okay. Let us consider the table size is 7 and the hash function is hash of x equal to x modulo 7, and the collision resolution strategy is the quadratic probing. So I square, insert 22, 30 and 50. The first step, initially it will be a empty hash table and first value is 22 divided by modulo 7, the remainder will be 1. So the 22 will get stored in the index position 1. Okay. The next value is 30. If you use 30, then the index position will be 2. It will be get stored in the index position 2. The next value is our next new value is 50. So 50 modulo 7, 7 7s are 49, the remainder is 1. So 1 is already occupied. So next square the index position, 1 square, 1 plus 1 square, that is 1 plus I square, the current I value is 1. So 1 plus 1 is 2, we have to check the 2 also it is occupied. Next we have to check the next we have to take this index position, right? So 1 plus 2 square, so the 2 square is 4. So 1 plus 4 is 5. So index position 5 we are checking. This index position 5 is null, it is unoccupied. So we can place this 50 in the index position 5. Okay, the next one is the double hashing. Double hashing is nothing but we can hash the, or we can double the size of the table. For that we have to use the hash of x plus I plus hash 2 of x modulo HTS, hash table size. For that you can consider this example. Here we are going to insert the 4 values. The hash function, first hash function is h1 of k equal to k mod 7. The second of it will be a h2 of k equal to 1 plus k mod 5. Okay. The previous one is empty table. Okay. 22 modulo 7 is equal to 6. So the value 6 in the it will be get stored in the index position 6. The next value is 43. 43 modulo 7, the remainder will be 1. So it will be get stored in the index position 1. Okay. The next key value is 692. So 692 modulo 7, the remainder will be 6. But the 6 is already occupied by the 27. So we have to calculate the H new. So H1 of 692 plus I into H2 of 692 modulo 7. This was the formula, right? So what is the previous value? 6. 6 plus what is the current I value? 1 into 1 plus 692 modulo 5. Table size. Okay. Modulo 7. So 9 modulo 7 is 2. We have to check the index position 2. Index position 2 is free. So occupy this place to save the value 692. Okay. This is the reference, and thank you.